Let us generalize all the concepts that we have studied about hierarchical modeling. We need to deal with multiple children. How do we represent a more general tree? How do we traverse such a data structure? In animation, how do we use this dynamically? Can we create and delete nodes during execution? For the humanoid figure shown here, we will have a tree structure like this with 10 nodes because there are 10 parts. Although it is up to us how we choose our root node, but we'd probably choose the torso, which is a good option because it is connected to most elements in this structure. The torso is connected to the head, and it is also connected to the upper limbs, the 4 upper limbs. Right, so left upper arm, left upper leg, right upper leg. And the upper limbs are respectively connected to the lower respective limbs. For example, the left upper arm is connected to the left lower arm. We can build a simple implementation using quadrics, ellipsoids, and cylinders to represent the body parts. We can access body parts through function calls such as torso, left upper arm, and so on. The transformation matrix stored in a node describes the position of the node with respect to its parent. For example, this M matrix positions the left lower arm with respect to the left upper arm. The tree structure with matrices would look like this. So the head only has the transformation matrix of that should be applied to the head. The left lower arm has the transformation matrix that should be applied to the left upper arm, and so on. There is a transformation matrix M for the right upper arm, the left upper leg, and the right upper leg. And there are similar transformation matrices for the lower limbs. To display the object that we just created, the humanoid object or the robot, we must traverse the tree. The position of the robot is determined by the joint angles or the transformation matrices of each part. Displaying of the different components of the tree require a tree traversal algorithm. The question is, should we do a depth traversal first or a width-wise traversal first? This can have an impact on how the object is rendered. So the details are given in your book, so I'd encourage you to read the book. But the general algorithm that we would follow is to start traversal from left to right and then start with the leftmost node, go all the way to the leaf node, and then pick up the next node and go all the way to the leaf node and go on. So from left to right and from top to bottom. So once we select a leftmost edge or joint, we must go all the way to the leaf node and then move to the next edge. We must visit each node once so that the transformation to a node is applied only once. And this is the reason why we have chosen this traversal algorithm. We'll call the display function at each node that describes the part associated with the node, and this will involve applying the correct transformation matrix to the position and orientation of the part. Now remember, there are 2 types of transformations applied to each part. One is the transformation that places the part to make the object, and the second transformation is applied to move that part to perform that respective animation. There are 10 relevant matrices. M positions and orients the entire figure, so that's the main matrix of the complete model. So it will position the torso with respect to the remaining nodes. MH positions the head with respect to the torso, and then M, LUA, RUA, they stand for the lower upper arm, right upper arm, and so on. They would position the upper arms and legs with respect to the torso. And then MLLA and RLA, they would position the lower parts of the lens with respect to the corresponding upper limbs. For more natural and less robotic figures, we will study skinning as a procedure later that is commonly used in animation techniques. And it uses weighted averages of transformations to move the object rather than rigid transformations to every part. So the weighted averaging of this transformation gives it a more realistic kind of movement.